My main objective of the project was to uh, means machine learning and text analytics applied to clinical data, trials data. The data set I have picked from the Kaggle. So the major question that I wanted to check what is the predictive power of unstructured summary text when combined with the structured phase data. So the data set that I have picked from Kaggle is regarding the trials, and also currently I am working on same domain where clinical trials happens. So that is the reason I have picked this one. So this data set contains structured trial phase data, and there are summary text which is a brief description which is unstructured. So that was the reason I wanted to look for the uh, predictive power when it is being combined with the structured with the unstructured one. So I have used two analysis classification for prediction for trial stress and the regression to predict the enrollment size. And the data that I have used for trials are being conducted throughout 1984 to 2020. This is 36 years of data. And to begin with, before I begin, so these are the stakeholders which will be benefited through the this particular project. So I have to begin with this project. I have firstly audited the data set, and I have seen a few missing values in the phase column. Many of you might be aware of the phases the clinical trials go through. It's like phase one, phase two, phase three, and phase four. So while auditing this particular data, I found out there were around 400 cells in the phase column were empty, which is around 1.91% missing values. So I had fixed that with not specified keywords. Then I tried to find out the duplicates. Fortunately, there was no duplicates in the data set. And then I move forward with the EDA, where I have used univariate analysis and bivariate analysis. Then I began with the feature engineering, where I have pulled 524 features using with three categories, I would say. The one phase features, where I have used ordinal and one hot binary. So ordinal, and then I have used in a text feature. So as I mentioned, there were a few unstructured data in a summary column. So it has very valuable information. So that's the reason I used text TF IDF to get maximum features from the unstructured data. And then I also worked on the domain keywords, like medical domain keywords, uh, which was the seven features I was requiring for a model training to identify the details. And then I used unsupervised learning for the LDA modeling, where 10 features that I pulled. So these are topics mainly on uh, the medical condition that people have, like cardiac arrest or few other cancer. So that type of information I used to get the top 10 topics from LD. The models that I have trained, so as a baseline, I have choose random forest. So, and the result, I will be sharing the result in further slides. Okay, so I have trained linear regression and random forest, and the advanced model that I used is XGBoost. And I have tried deep learning models as well, but the idea behind to try deep learning as to see how it performs on the lower data. As I remember, one of the class we had a discussion about uh, to use deep learning, we should be having more than 50,000 records in the dataset, and my dataset had 13,748 records. So I just wanted to see how it performs on that. Then I did tuning while training the model, and then I evaluated the scores. So this is the result each model has get. So as I mentioned, I did two analysis, classification and regression. So first table shows the classification analysis where XG boost model was the best performer, which trained on the data with 92.47, and the test result was 81.46. And the baseline, as I mentioned, random forest was the baseline, which was almost perfect in a training, but had low test result compared to the XGBoost. And for the deep learning, I identified that it is overfitting because of the data size. Because I didn't had as I mentioned, the summary column had brief description in it. It had no lengthy explanation about the uh, details about that particular trials. And that is the future thing I want to try to see, include more details or pick trials related data which has more data set is bigger in size. And then the regression result is for training it is good, but for test purpose for R square it's 27, which is 21.4% improvement compared to the structured one. So text features improved a lot in prediction compared to the just structured data. So these are the top 10 most important features. And if you see the topic features contributed 39%, which is 8x more predictive power than phase features, which is 4.8. So phase feature is like a structured data which has uh, phase numbers in it. So it also proves that text analysis is essential in this particular project to predict the next. Okay, and this is the predictive power feature category. So basically, I have used text-based features and the structured features. So topics, domain, and text metrics are the text-based feature, which contributes 72.6 predictive power from unstructured text, and the structured text, which includes phase and temporal, which has 27.4 from traditional data. So it means unstructured text provides nearly 3x more predictive power than the structured data. So these are the topics that I have is taken using LDA. And these are the themes: oncology, chemo, as I mentioned, cancers. Those top keywords I have used to identify these themes. So it is unsupervised learning. So
Hi,
system,
Pradeep.
yeah,
We are out of time. Could you
yeah,
wrap
sure,
this up?
sure. Okay, so these are the hypotheses testing I tried, and these are the results, and these are the some findings that I in the project. And as every project has its limitation, so in my project there was a limitation like data size, and as you have seen the r2 squared r squared variance is 0.27. It means 27% of data variance we have explained, but 73% are unexplained. So this is the current limitation, and this is what I wanted to explore in uh, as a enhancement to the this project. Okay, so these are the at right side, the next steps that I want to follow along with the improving the data set. And this is the question that I initially thought, and this is the answer we have received from this particular project. Yeah, this is the data set code and key references that has been attached. Yeah, any questions?
Okay. Okay. This is good. This is good. Okay. Yeah. Yeah. Yeah.
Thanks.
Can